So in the second part of 9.1, we're going to look at, statistical significance, as well as what the significance level means, and then we're going to look at type 1 and type 2 errors in context. Talk about the consequences of each. Quick reminder about the reasoning of significance tests. We make a decision about the parameter. We call that the null, that we need convincing evidence to reject that null. And the way it's done is we make our hypotheses. In this case, the hypothesis would be that the proportion is equal to 80, and we think they're not as good, and the alternative hypothesis would be less than 80. And all of this is a distribution assuming that an 80% free throw shooter, it is true that they're an 80% free throw shooter. And then we look at the statistic coming from some sort of collection of data. In this case, when they did 50 shots, they only got a 64%. Then we look at that 64%. How often did that happen by chance? Not very much. So then we have strong evidence to reject the null, and strong evidence in favor of the fact that they're probably not a 80% shooter. So there's two possible explanations when he got a 64%. One is that the null hypothesis is correct, he really is an 80% shooter, and just by chance this very, very unlikely outcome occurred. The other possible occurrence is that the alternative hypothesis is correct, and the proportion is actually less than 80%, so the sample result is not an unlikely outcome. So the outcome that would rarely happen if the null hypothesis were true is good evidence that the null hypothesis is not true. That's the basics. How low a p-value needs to be before we reject the null is called the significance level. And that significance level is agreed upon ahead of time. It's agreed upon by the researcher. And the significance level is chosen ahead of time based on a couple different things. If the null is something that's been accepted for a really long time, strong evidence will be needed for people to change their minds. And so they might choose a smaller significance level, like an alpha of 1. Oops, I can't draw. And then the other reason that we might want a lower significance level is if we want to make sure that we're correct in our rejecting or not rejecting, then we want to make that window as narrow as possible. So depending on your level, you might have a different conclusion. And so once again, we know ahead of time what the alpha is going to be. So here's an example when we would have two different results depending on the alpha that was chosen by the researchers. And so this is a situation where Gallup poll reported that 72% of teens say they seldom or never argue with their friends. And Yvonne wonders whether this result will hold true in her large high school. So the null hypothesis is this population parameter of 72, and the alternative, she doesn't know whether it's going to be bigger or smaller, so she's saying that the alternative is that it's different than 72. By the way, this would make this a two-tail. We'd be looking at both the test statistic and its absolute value. And we're looking at both of the areas above and below. Let's say the p-value is 0.0291. A significance level of alpha is 0.05. Since the p-value is less than the significance level, we reject the null because that provides convincing evidence that the percent of teens that seldom or never argue with their friends is different than 72%. Now, if we're asking for a more tight level, alpha level like 0.01, and we agreed upon that ahead of time, the p-value is more than the significance level, so we fail to reject the null. We don't consider that convincing enough evidence at an alpha level of 0.01. So when we draw a conclusion from a significance test, either we choose to reject the null based on conclusive evidence or fail to reject the null based on a p-value that's higher than the alpha level, we could be wrong, and there are two types of mistakes that we can make. So if we reject the null and the null is actually true, we've committed what is called a type 1 error. So in that case, we reject, but it's actually true. That's type 1. And if we fail to reject when it actually is false, that's a type 2 error. So that's the equivalent of letting once again, that's the equivalent. A type 1 error is the equivalent of an innocent person being convicted of their guilt when they are indeed innocent. And a type 2 error, failing to reject the null, means that we still think they're innocent when indeed they're guilty and they're then been freed. There's other ways to remember type 1 and type 2. Type 2 is fail to reject. So if you fail to reject and that's a mistake, that's a type 2. So you're going to have to figure out some way to keep these track. So these type 1 and type 2 errors, you can actually calculate the probability that you're going to make a type 1 error, which once again is that innocent, even though that you're deemed guilty, you reject when you really shouldn't. This is exactly equal to the significance level, and if you want the mathematics behind that, you can go ahead and look at page 549 in your textbook, and it explains why the alpha is exactly the probability that you'll make that type 1 error. And really paying attention to what the consequences are of a type 1 error before you choose your significance level. So hopefully now you have a better understanding of statistically significant as well as what a type 1 and a type 2 error are.